Welcome to another unofficial Logic 2000 tutorial. In this chapter, we'll finish deriving problem 15 from the derivations in Chapter 1. In the last tutorial, we left off on a cliffhanger. What could we possibly do with line 6 if we can't use any of the tools that we've been given? Well, unless you've run across this technique in some of the earlier derivations, you might be at a loss. But it is tricky, so don't be discouraged if you don't know. What we need to do here is to try to show the opposite of line 6. Then, once we do, then we'll have a contradiction, and we can box and cancel this subderivation using indirect, as a contradiction will box and cancel anything. Now, what is the opposite of line 6? The opposite of line 6 is P, arrow, not R, and that's what we need to show. In order to do this, we can just type show unneg 6. That's show space UNNEG space 6. This stands for show on negation. And now we hit enter. And there you see how the computer has placed the opposite of line 6 on the new show line. Now we're back on familiar ground. Because we're in a line immediately following a show line, we need to make an assumption. What we assume depends on what's on the nearest show line. In this case, what's on the nearest show line is a conditional. So we'll assume the antecedent by typing ASS CD and hitting enter. Now what? Well, as before, we need to look back up on the nearest show line and see if it's a conditional. If it is a conditional, we always assume the antecedent, as we did on line 8, and show the consequent. We can do that now by typing show cons and hitting enter. Now what? Again, we're on a line immediately following a show line, so we need to make an assumption. And what we assume depends on what's in the nearest show line. This time, what's in the nearest show line is not a conditional. So, what do we need to assume, and how do we do it? We need to assume the opposite of what's in the show line. And to do that, we're going to type ASS ID and hit enter. Here we're just going to choose the simpler option, which will always be the first option, and just hit enter to get R. Next, we're going to look back up in the nearest show line and check to see if it's a conditional, in which case we always assume the antecedent and show the consequent. But, since what's in the nearest show line is not a conditional, we're done with our automatic steps, and are once again left to our own resources to figure out how we can apply the rules that we've learned to the lines that we have to work with, which are all the lines except the uncancelled show lines, that is, show lines without a line drawn through them. That means we can't use lines 1, 4, 7, or 9, but we can use the rest. So, which lines can be used with some of the rules that we know? Pause the video if you want to think about it. If you've looked carefully, you will have noticed that lines 10 and 2 contradict, so we can use them to box and cancel. So, how will we go about doing that? Well, we first need to bring down not R from line 2 into this subderivation by using the repetition rule. We do this by typing 2 space R and hitting enter. Then we can type 10, 11 space ID and hit enter to box and cancel. Now we can minimize the subderivation by clicking on the little minus sign next to the cancelled show line and consider what to do next. Well, we now have a new term to use, the not R, which was not available to be used before, because it was on an uncancelled show line. But now that that show line has been cancelled, we can use it. What do you think we can use it with? As usual, the first thing that I'd like to try doing with a new term or formula is to see if I can use it to box and cancel the current subderivation. In order to do that, I start by looking up at the nearest uncancelled show line and seeing if it's a conditional, which the show line on line 7 is, and then seeing if we have the consequent of that conditional somewhere in the current subderivation, but not on an uncancelled show line. The consequent of the conditional on the nearest show line, line 7, is not R, and it just so happens that we have not R within our current subderivation on line 9. So we can box and cancel. Now, what do we need to type here in order to do that? What we need to type is 9 space CD and hit enter. Now we can minimize the boxed and cancelled subderivation and think of what we need to do next. Once again, we've got something new, which is P arrow not R, which we couldn't use before because it is on an uncancelled show line, but which we could use now. Now, how can we use it? Pause the video if you want to think about it. Now, to figure this out, it might help for you to remember why we were showing line 7 in the first place. On the computer screen before you, there's a hint in the middle column on line 7. The hint is show unneg. That might help you to remember that we were showing line 7 because it is the opposite of line 6. Since these lines are opposites, we have a contradiction. And since we've got a contradiction, we can box and cancel by indirect by simply typing 6, 7 space ID and hitting enter. Here we didn't have to repeat any line because lines 6 and 7, the lines we're using to box and cancel, were already in our current subderivation. Now we'll want to just go ahead and minimize the boxed and canceled subderivation and think of what to do next. Once again, we've got a new term to play with here, Q, which we couldn't use before, because it was on an uncancelled show line. But now that the show has been cancelled, we can use it. And again, the first thing that I would see is if I could use it to box and cancel. Turns out that I can, since Q is the consequent of the conditional on the nearest show line. So we can just type 4 space CD and hit enter. Now that the whole derivation has been finished, you can just click check or press Ctrl K, and you should see correct in the upper right hand corner of the derivation window. If not, you'll see some line flagged with an error, which you'll want to fix before checking your derivation again. So, we're done with this derivation, but before you go, I'd like to comment on something that you've probably noticed, which is that these derivations tend to contain a lot of very repetitive, nearly or completely automatic procedures. This is not an accident. By seeing the same sorts of things, and following the same procedures in derivation after derivation, you become intimately familiar with the rules of modus ponens, modus tollens, repetition, and double negation, and the various ways of boxing and cancelling. Soon you'll be able to do these derivations with your eyes closed and be ready for Chapter 2. Those of you who find these routines a bit boring shouldn't worry that all of logic is like this. There are plenty of creative, challenging, non-automatable, and exciting problems in advanced logic waiting for you. But you do have to get familiar with the basics of logic first, which is what this class is all about. Still, even the basics will get more challenging as we go from chapter to chapter. Alright, that's it. See you next time.